In part one, we talked about the ideas and the terminology behind functions. Now we're ready to write them. The most important thing in a function is the very first line, where you give the name of the function, the kind of thing it returns, if any, and the inputs it takes. Everything else is just regular processing code that we've seen before. So let's see how to write that very first line. I'm going to take, for our example, the idea that we want to write a function that takes three numbers, we'll say that they're floats, adds them up, and returns their sum. Of course, we're going to write much more interesting functions, but this keeps things simple and it lets us focus on the key issues. So how might we write this down? How might we say that this is the thing we're interested in? Well, we could write it in English. We want to create a function named add three numbers, takes three floats, and returns a float. Now, you might have guessed this is not what we type into processing, but it's not that far off. And by starting with this, which I think we can read and understand, I'll show you how we kind of add and subtract and tweak it to turn it into processing language for this. And then you'll be able to read the processing syntax and know that it means this. So the first thing I'm going to do is I'm going to get rid of the words function named, because processing is going to be able to figure out that this is a function from the rest of the declaration. So let's just get rid of that. Now let's look at the three floats. I'm going to take that and wrap it in parentheses. This is the way that we tell processing these are the inputs, by wrapping them in parens. All right, we're really making great progress here. We're going to get rid of a superfluous word, takes. It knows that it takes the three arguments because they appear right after the name of the function. So let's get rid of that. Now I'm looking at the words three floats. Well, I don't want to say three floats. I want to actually tell processing the names of the three floats I want to use, so I can refer to them in my program. So I'm going to make up names for them and separate them by commas. So I'm going to call them A, B, and C because that keeps things simple for this demonstration, and I'm going to declare each one with its type. Now that we have that set up, let's take a look at the last four words, and returns a float. Well, you might have guessed, and we don't need, A we don't need, so we kind of just want returns float. It turns out we don't need returns either. The only word that's really important here is the word float, and that comes at the beginning of the line. So I'm going to get rid of those things, and I'm going to stick the word float at the front. Well, we're not quite done. We actually have to provide the routine itself. The routine itself is provided between curly braces. The open curly brace starts the function, the closed curly brace ends the function, and the function itself goes between the curly braces. There's only two things missing here: the body of the function, where we actually somehow add together A, B, and C, and then some mechanism for returning the sum. Here's that mechanism. It's the word return, open paren, the value you're returning, close paren, and then a semicolon at the end because it's a statement. Typically, this return F would be on a line by itself, but again, I'm squishing everything together. So let me show you a little bit more about this return business, how it works, and what it means for a function to return something. Here's our function add three numbers that we just constructed. All I've done here is I have a comment for the line where I'm going to put the function. Well, this is going to be a two-line function, so I'll make a second line with a second comment. First thing we're going to do is to add three numbers. Then, once we have the sum, we will return the result. So let's write those two lines. First thing I'll do is add three numbers, so let's call it sum. So I create a floating point variable called sum, and I just add A, B, and C. Now I want to return the result, and we saw before we use the keyword return. Open paren, the value we want to return, close paren. You can only return one thing, one int, one float, one color, one something. We'll see later if you want to return whole batches of stuff, there's a way to do that. But for now, you just return one thing. In this case, we're returning the variable named sum. So what does that mean, return? I'm talking about returns and giving things back. Well, the idea is that we call add three numbers just like we call rect or size or any other function we've seen, but in this case, it gives us back a value. So I'm creating an imaginary draw, and you can see I have a line called float sum1 equals add three numbers, 3, 4, 5. This line says, call the routine add three numbers with the values 3, 4, and 5. It says, okay, I'm going to go off and find add three numbers. It checks add three numbers, and it says, oh, I'm expecting three floating point numbers. It looks at the call, and it says, oh, I'm getting three numbers, 3, 4, and 5. Happily, if a routine is expecting a float, you can hand it either a float or an int. Because really, you can think of an int like 3 as the floating point value 3.0. It doesn't go the other way around. If your routine is expecting an integer and you hand it a float, it will raise an error because it says, you're handing me a floating point value and there's no reasonable way for me to turn that into an integer in a way that might not surprise you. But turning 3 into 3.0 is always reasonable. So it says, all right, now I'm going to match up the three variables, A, B, and C, with 3, 4, and 5 in order. So A becomes 3, B becomes 4, C becomes 5, and now it executes the lines inside of add three numbers. Sum is A plus B plus C. Well, that's going to be 3 plus 4 plus 5. Computes the number, sticks that into sum, and then it sees return sum. Now it goes back up to the line where we called it, float sum1 equals add three numbers, and it says, okay, now I have a number I can stick into sum1. And it's the number 12, 3 plus 4 plus 5. If we want to add up three different numbers, we can call add three numbers again and again and again with any variables we want. There are two interesting things I want you to observe here, and they're both in the very first line, in void draw. Notice that draw has an open paren and a closed paren, but no arguments. Draw is a function, just like any other function, just like add three numbers is a function. It doesn't take any arguments. It has no inputs. The way we tell processing you take no inputs is there's nothing between the parentheses, but you have to give it the parentheses. That's part of how processing knows that that's a function declaration. So if we have a function called add three numbers that takes three floats, we list them. If we have a function called add three numbers that for some mysterious crazy reason takes no inputs at all, we would just have open paren, closed paren with nothing inside. That's the way we tell processing no arguments. You've got to have the parens. You just don't need to have anything inside them. The other thing I want to talk about is on the first line. It's the first word there, void. Now what the heck is void doing? Void is the way we tell processing this routine doesn't return anything. Notice that add three numbers is of type float. And sure enough, there's a return statement and it returns sum, and sum is a float. Everything's great. Draw doesn't return anything. Let me show you how the inputs or the arguments to a function take on their values. Let's suppose that we have a piece of code like this. At the top, I'm calling a routine called paintbox, and I'm handing it two numbers and a color, in this case a yellow color. Underneath, we see the declaration for paintbox. It begins with void, so it doesn't return anything, and we don't care about that right now. What we really care about is the rest of the line, float ulx, float uly, color, clr. In the body of paintbox, just after the comment, we fill with the color clr, and we draw a rectangle with its upper left corner at the values of the variables ulx and uly. But notice nowhere do we say ulx equals something or uly equals something. We don't even say color equals something. Those three assignment statements are done implicitly for us by processing when we call the function. In the first line of paintbox, I have a little comment, and in there I will show you what the values of ulx, uly, and color get set to for the particular call at the top of the screen. So let's begin by looking at the top of the screen, and we see that the first argument we're handing to paintbox is the number 100. When paintbox gets called, processing looks at the argument list and it says, oh, the first argument is ulx, and the first argument in the list at the top is 100. In the argument list, we say ulx has to be a float, And sure enough, 100 can be a float. So I'm going to take the value of 100 and put that into ULX. In essence, it's like saying ULX equals 100, but it's done for us automatically. Now let's look at the second argument, ULY. Where does that come from? Well, look at the call. The second value that we're handing to Paintbox is 200. So that gets put into the second argument, which happens to be ULY. So the value 200 gets put into ULY, or implicitly we're saying ULY equals 200. Finally, the color. It works exactly the same way. At the top of the screen, the third value that we're handing to Paintbox is a color called yellow color. In the declaration for Paintbox, the third argument is a color, clear. So processing says, I know what to do. I'll take the value of yellow clear and put it into clear. Essentially, it's doing an assignment. Clear equals yellow clear. And now with those three assignments done, it can then do the fill and the rect and everything else as usual. The beauty of all of this is that if we put different values into our call to Paintbox, then the assignments implicitly get changed as well. In other words, ULX, ULY, and clear will always have the values corresponding to the function call at the top of the screen, no matter what values we put in there. We've seen the basics of creating a function, handing it variables, and getting a value back from it. In the video on using functions, I show you how to take this information and really use it to create functions that are going to be useful for you.